Okay. All right, section 9.5, the sine, that's how that's pronounced, S-I-N-E, sine, and cosine ratios. Our objective is to use the sine and cosine ratios, find the sine and cosine of angle measures in special right triangles, and solve some real-life problems involving sine and cosine ratios. So before we can talk about sine and cosine ratios, we need to talk about the one we talked about yesterday. If you remember in our last video, we talked about something called a tangent. The tangent ratio, okay? The tangent ratio is the tangent of an angle is equal to, again, the opposite side divided by the adjacent. And so any angle, again, any acute angle in a right triangle, again, we're specifically talking about right triangles. Okay, we're talking about right triangles. But if I have a right triangle, so I'm pulling out our old note, 9-4 notes, you should look familiar, okay? So if you don't have them and you'd like to look at your own notes, you can go ahead and push pause, get out your 9-4 notes, okay? When we first started talking about tangent, in section 9.4, we were looking at the fact that any right triangle that has one of the acute angles the same will be similar, which means their sides will be in proportion. So it doesn't matter, any right triangle that I have, that this angle is the same as this one, the ratio of the opposite to the adjacent will be the same. Okay? We didn't talk about the hypotenuse at all. But the hypotenuse is just another side in the right triangle. So really, the ratio of any two sides will always be the same. So I could do the ratio of the opposite over hypotenuse. So instead of doing opposite over adjacent, I could do the opposite side over the hypotenuse. So I could do the opposite side over hypotenuse. Or we could do the adjacent side over the hypotenuse. Or any other ratio of any of these sides will always be the same because this triangle ABC is similar to this one XYZ, which tells me that any set of their two sides are going to be in proportion, meaning the ratio is going to be the same. We have a special name for the ratio of the opposite to the adjacent, meaning the opposite side over the adjacent side. We have a special name for that. We call it the tangent. Today we're going to be learning two more special names. One of them is sine, S-I-N-E. We abbreviate it S-I-N, okay? But again, we say it sine, S-I-N-E. So here we would say the sine of A, the sine of angle A. So we're looking at angle A here. So here in this triangle, if we're looking at angle A right here, there's the side opposite angle A, which is right here. There's the opposite of angle A. We have the side adjacent to angle A, and then we have the hypotenuse. The hypotenuse is always the hypotenuse, no matter what angle you're looking at. So the sine of angle A is also a ratio, just like our tangent was, but the sine is the ratio of the opposite leg over the hypotenuse. So sine is the ratio of the opposite leg over the hypotenuse. Tangent, if you remember, the tangent of angle A would be opposite over adjacent. We write it that way, OPP over ADJ. Opposite over adjacent. So the tangent of this angle, the tangent ratio is the opposite over the adjacent. The sine of this angle is opposite over hypotenuse. Again, this all comes from that similar triangle idea. And then we have one more called the cosine. Let's switch colors. Let's use blue. Cosine here. Cosine, we abbreviate COS. But again, when we say it, we say the cosine of A. I don't want to hear any conversation sin A, cos A, tan A. No. Sine of A, cosine of A, tangent of A. These are just the abbreviations, okay? But the cosine of A is the adjacent leg over the hypotenuse. So it's the adjacent over the hypotenuse, okay? So adjacent leg over the hypotenuse. Okay, adjacent over hypotenuse. So the shorthand way we write these is tangent of A is the opposite side over the adjacent side. The sine of A is the opposite over the hypotenuse. Okay, and the cosine of A is the adjacent over the hypotenuse. Okay. All right, I don't know about you, but I'm kind of a little concerned. How are we going to keep these ratios straight? How are we going to keep these straight? How are we going to make sure that we know tangents opposite over adjacent and not get it mixed up with sine, which is opposite over hypotenuse? Okay, or get sine and cosine goofed up. They're both over hypotenuse, but one's opposite, one's adjacent. How do we keep them straight? Okay, we actually have a bit of a mnemonic to help us keep them straight. Where it comes from is sine, S, is opposite over hypotenuse. So we would write that as SOH, S-O-H. Sine is opposite over hypotenuse. Okay. Cosine is adjacent over hypotenuse. So we would write that C-A-H. Okay. And then last we have our tangent. Tangent is opposite over adjacent. T-O-A. So really we remember SOH, Ka-toa. So-ka-toa. Okay? Kind of sounds like a bit of a language. So-ka-toa. So-ka-toa. Okay? And that helps us remember that sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Okay? There are many other ways, and there's many ways of helping us remember this so-ka-toa idea. Okay, one way is with song. There are so many songs that go with so-ka-toa. People are making them up all the time, making little music videos. Okay, so what I want you to do right now is I want you to pause this video. I want you just to go to general YouTube. Go to YouTube. And in the search bar, I want you to search so-ka-toa. You can do it all caps with no dashes. You could search so-ka-toa. You could put dashes in it. Do it lowercase. C-A-H-T-O-A. Okay, you could do it caps with dashes. You can, but I want you to search so-ka-toa, and I want you to find a music video that you like. There are many, 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 many music videos that go to so-ka-toa. I want you to find one that you like. Okay, once you find one that you like, I want you to copy the link. Okay, I want you to copy the link. So go up, shade the whole entire link, copy it, and then below my video on my web page, there is a link that says song link. I want you to click on that and put in your name. Underneath mine, I've done the first one. So you can feel free to go ahead and watch my video. I did post a video there. But we're basically going to be creating a Google document that has all different kinds of music videos on it. Okay, so you're free to go ahead and watch anybody else's videos that they've posted. Just click on the link. It'll open up in YouTube and you can watch their videos. But I want you to go ahead and post your video. Find a music video that you liked. Okay, it'd be awesome if it was one that nobody else picked. It doesn't have to be. If you found a video that you love and you want to post it, go ahead. But it'd be awesome if we just had a lot of different types of videos instead of just the same one over and over and over again. Okay, so I want you to, again, so go to YouTube, find a music video that goes over so-ka-toa, and then copy that link and paste it on that Google document. You don't need to worry about saving it. Just post your name in the Google document, paste your link, and then close it. It should save. Okay, all right, so keep those ratios straight. Okay, so let's go ahead and let's practice. So once you've done that, okay, then come back and finish this video. Okay. All right, so I hope you finished watching your so-ka-toa video. Okay, I really like the black and yellow one, but there's a lot of different ones to choose from. Okay, but now let's actually do some examples using the so-ka-toa. So the sine, cosine, tangent. So first this example 1, we want to find the sine of angle A, find the sine of angle B, the cosine of angle A, and the cosine of angle B. Write each answer as a fraction and as a decimal. So first, let's go ahead, let's find the sine of angle A. So to keep my angles separate, I'm going to label them. So here's my pink. So I'm talking about the pink angle. This one would be opposite of A. This one would be adjacent. This one's always the hypotenuse. So if we're looking at angle A, for sine of angle A, I'm just going to write down what I'm going to do first. I want opposite over hypotenuse. So look at where angle A is. Angle A is right here. I want the opposite side, which is 15, over the hypotenuse, which is 39. So the sine of angle A is 15 over 39. So now we want to simplify that fraction. 15 over 39 is that as a decimal. So we could write the approximate is 0.38, 4 decimal places, 4.6. Okay, but then we want to math, enter, get it as fraction symbols form, 5 over 13. So here's the exact, here's the approximate, 2 4 decimal places. So the sine of angle A is 5 over 13, or approximately 0.3846. Now we want to find the sine of angle B. Okay, so we want to find the sine of angle B. So that's a different angle. So I'm going to switch colors. The sine of angle B. Angle B is down here. So the opposite of angle B now is over here. This is now the opposite of angle B. This is now the adjacent of angle B. But again, this is still the hypotenuse. It's the hypotenuse regardless. Okay. So the sine of this angle B would be opposite, which is 36 over hypotenuse, which is 39. Again, we're still doing opposite over hypotenuse because we're still doing the sine. The sine of angle B opposite, which is 36, over hypotenuse, which is 39. So 36 over 39 as a decimal is approximately 0.9231 if we go to 4 decimal places. Math, enter, as a fraction is 12 over 13. Okay. Sine of angle A. So now let's go back. Now we want the cosine of angle A. So we now want the cosine of angle A. Again, this is not a multiply here. This time I'm taking the cosine of what? I'm taking the cosine of angle A. So cosine is adjacent over hypotenuse, adjacent hypotenuse. So I'm going to write adjacent hypotenuse. So the cosine of angle A, again, here's angle A. The adjacent to angle A is right here, 36. The hypotenuse is 39. Well, we just did a 36 over 39. That was approximately 0.9231. Hey, and it simplified to 12 over 13. No point in doing something twice when we already did it once in our calculator. Okay, and then last we have the cosine of angle B. Cosine of angle B is again adjacent over hypotenuse. Again, we're looking at angle B here, so adjacent would be the 15. The hypotenuse would be the 39. Well, we did 15 over 39 right here. It's approximately 0.3846, okay, which simplifies to 5 over 13. So there's the approximate. There's the simplified exact, 5 over 13. Okay, and so I want you to notice something. Did you notice here that the sine of angle A was the same as the cosine of angle B, and that the cosine of angle A was the same as the sine of angle B? Notice we had the same thing here and the same thing here. Okay. This leads us to a little bit of something that could be kind of helpful. If you look at this triangle, angle A and angle B, okay, are complementary angles. Because this is a 90, we know angle A plus angle B plus angle C have to be 180, right? But angle C is a 90-degree angle. So if we subtract that 90 degrees from both sides, we know angle A plus angle B has to be 90 degrees. So we say angle A and angle B are what we call complementary angles. Any two angles that add up to 90, do you remember, are complementary? So angle A and angle B are complementary angles. So here, angle A and angle B are complementary, but the sine equals the cosine of the other, okay? So what that leads us to believe is, and it will prove to always be true, is the sine and the cosine of complementary angles are equal. So if angle A and angle B are complementary, then the sine of A equals the cosine of B. And the sine of B equals the cosine of A. So the sine and the cosine of complementary angles are equal, okay? So we can actually use that to find sometimes sine and cosine of other angles. For example, they want you to write the cosine of 69 degrees in terms of sine. So if I knew the complement of 69 degrees, so 69 degrees and what's its complement? 69, well, 90 minus 69. 69 degrees and 21 degrees are complementary. Since they are complementary, we know that the cosine of 69 degrees equals the sine of 21 degrees, okay? And we can use our calculator to verify that. Again, make sure you're in degree mode. But the cosine of 69 degrees, the approximate is 0.3583. The sine of 21 degrees, 0.35, exact same thing. So here we wrote the cosine of 29 in terms of sine. The cosine of 69 degrees equals the sine of 21 degrees. Okay. So these new sine and cosine ratios can actually help us find the missing sides and missing pieces of triangles. Okay. For example here, we want to find the values of x and y using sine and cosine. Round your answers to the nearest tenth. Okay. So this is the angle we know. We know this angle here. If this is the angle that they give us, x here is the side opposite that angle. Y is the side that's adjacent. Okay. But they give us the hypotenuse. Okay, so opposite is the side we're trying to find. Let's find x first. We're trying to find opposite. We know hypotenuse. Well, the ratio of opposite over hypotenuse is sine, SOHCAHTOA. So it's helpful at the top of all your papers to write your SOHCAHTOA down to help us remember your ratios. Opposite over hypotenuse is sine. So I know the sine of this angle is equal to opposite over hypotenuse. So we'd write that down. The sine of 35 degrees is equal to the opposite side, which is x, over the hypotenuse, which is 53. And we can solve this just like we solved the tangent problems. I'd write this over 1. Means extremes. 53 times the sine of 35 equals x times 1, which is x. So basically, x is going to equal 53 times the sine of 35 degrees. So I can just type it in, 53 times the sine of 35 degrees, which is 30 point, and says to the nearest tenth, 30.4. So x is approximately 30.4. Okay, so there's to find x. Now, if we want to find y is the adjacent side. Again, they tell us the hypotenuse. So adjacent hypotenuse is cosine. So the cosine of 35 degrees equals the adjacent side, which is y, over the hypotenuse 53. Again, put that over 1, means extremes. 53 times the cosine of 35 equals y. Okay, so again, I would take 53 times the cosine of 35, their calculator, and y is approximately 43.4. So we were able to find x, we were able to find y. Okay. All right, now we want to find the sine and cosine of a 45-degree angle. We want to find the exact sine and cosine. We can get the approximately. Sine of 45 degrees is about that. cosine of 45 degrees. It's about that same thing. So the sine and cosine should be the same thing. Okay, so let's go ahead and let's label this triangle. We'll go A, B, C. And this is a 45 degree angle. 45, 45, 90 triangle. Okay, and so let's just make up some side lengths. Well, I know the legs are congruent, so I don't know. Do you want to have them each be 5? I just picked 5 at random. You can pick any number you want. You'll see it won't matter. And in a 45 degree 90, if we remember, the hypotenuse is equal to the leg times root 2. Well, my leg is 5, so this hypotenuse would be 5 root 2. Okay. So let's go ahead and let's look at this angle right here, this 45 degree angle right there. So we're looking at that angle. This one over here would be opposite. This one here would be adjacent. Here's my hypotenuse. Okay, so let's find sine first. So let's find the sine of angle B, the sine of our 45 degree angle, angle B here. Okay, the sine of this 45, this angle B, would be sine, so opposite hypotenuse. So opposite 5 over hypotenuse, which is 5 root 2. Okay, so I'm going to write this as 5 times 1, so my 5 divided by 5's cancel. So I'm left with 1 divided by root 2. Simplify that, let's multiply by root 2, so I'd get root 2 over root 4. Root 4 is 2, so root 2 over 2. So the sine of 45 degrees is the square root of 2 divided by 2. And if I approximate the square root of 2 divided by 2, I get the 0.7017. So that's the sine of 45 degrees. Now the cosine of 45 degrees. Okay. The cosine of 45 degrees would be adjacent over hypotenuse, which the adjacent is also 5 over 5 root 2. So really, we're at the exact same spot we were here, 5 divided by 5 root 2. So we can kind of skip those simplification steps because we already did it, and we get root 2 over 2. So the sine of 45 degrees is square root of 2 over 2, and the cosine of 45 degrees is the square root of 2 over 2. Okay. All right, now let's do that for a 30 degree angle. Do that same process. So we have A, B, C. There's my 90. Okay, here's my 30 degree angle. Okay, so this is my 30 degree angle. Over here is my opposite. Here's my adjacent. Here's my hypotenuse. Okay, again, remember the hypotenuse in a 30, 60, 90. The hypotenuse is equal to the short leg times 2. And the long one is equal to the short times root 3. Okay, so let's go ahead and let's, this one across from a 30, this is my short leg. Here's my long one. And of course, there's my hypotenuse. So let's just pick a number for the short leg. I don't know, 1? So that would mean the hypotenuse is 2, 1 times 2. And the short leg is 1 times root 3, which is, sorry, the long leg is equal to short times root 3. So this one would be 1 times root 3, which is 1 root 3. Okay. So let's go ahead and let's find the sine of 30 degrees. Sine of this angle, sine, so opposite over hypotenuse. Opposite 1 over hypotenuse, which is 2. 1 over 2. Oh, well, that's nice. Sine of 30 degrees is 1/2. And we can check that with our calculator. The sine of 30 degrees is, hey, 1/2. That one was nice. So now we need to find the cosine of 30 degrees. That would be adjacent, which is the square root of 3, over hypotenuse, which is 2. Square root of 3 over 2. I can't actually simplify that, so we'll leave that as it, square root of 3 over 2. So let's see, the square root of 3 divided by 2 is 0.866 approximately, while the cosine of 30 degrees is 0.866. So we found the exact sine and cosine of 30 degrees. Okay. All right. In our last lesson, 9-4, we talked about the angle of elevation. That's measured, again, this is 9-4 notes. I still have out 9-4 tangent. That's measured from the horizontal looking up, elevating. Okay, today we're going to talk about an angle of depression. That's looking down. Again, depression is going down, right? You depress something, you're going down. If you are depressed, you're feeling down. Okay, so that means if I'm standing up here, let's call this point A. Point B would be a point down here. The angle of depression, again, would be measured from the straight horizontal. So I draw in my straight horizontal as a dotted. The angle of depression going from A to B would be this angle right there, looking down. Okay. Right, so here in extra example 6, as I'll ask example, then we'll be done. You are skiing down a hill with an altitude of 800 feet. That means the total height of the hill is 800 feet. So if down here is ground zero, so if down here's the ground, you're up here at the top of the hill, the altitude or the height of that hill, this distance right here, is 800 feet. Okay, so you're skiing down this hill. Okay, so you're skiing down, you're going down this hill, down, down, down this hill. The angle of depression is 15 degrees. Be careful. Do not put 15 degrees into here, because the angle of depression, you're starting up here on the hill, this is where you're starting, up here at X. The angle of depression is always measured from the horizontal. Measured from horizontal. So I need to draw in the straight horizontal from where I start. So there's my straight horizontal. The angle of depression would be this angle going down right there. This angle right here is the 15 degrees. We want to find the distance X. You are skiing down the hill to the nearest foot. So we're looking for this distance down the hill. From here, let's label this A, label this B. We're looking for that distance, and we know this angle. Okay. A couple different ways you could work this problem. One is, this is a straight vertical. I'm just going to draw in a straight vertical over here. You can draw in more than what you need. And since this is straight horizontal, so is this. These are both straight vertical. This here is also 800 feet. So triangle I'm going to look at is this triangle right here, this actual top one. That one right there. Okay. So here's the angle I know. Okay, it's a right triangle because we have a straight horizontal, straight vertical. Okay, the side that I know is the opposite side. This is the opposite side. The side we're trying to find is the hypotenuse. So I look at which trig ratio has the opposite and the hypotenuse. Opposite, sine, starting out, OH, opposite hypotenuse. So the sine of my angle, A, would be equal to the opposite side over the hypotenuse. Well, this angle is 15, so the sine of 15 degrees equals the opposite side, which is 800 feet, divided by the hypotenuse, which is X. Okay, so to solve this, again, we can use our means extremes and put this over 1. Okay, so here we've got our mean, so let's multiply these two here. So we'd have X times the sine of 15 equals 1 times 800, which is just 800. Okay, so this is X times the sine of 15. Again, the sine of 15 is just some number. It's about that, okay, 0.25. So to get X by itself, I'm going to have to divide both sides by the sine of 15. So these divide out, so X would be approximately, it says to the nearest foot, so we can round. So we're going to take 800 divided by the sine of 15, and we get 3,009, and then that 9 is going to round that to a 1 feet. So 3,091 feet. Okay. Okay. Go ahead and write down your practice. Don't forget to put that link in for your video that you found, and come see me if you need help.